Plane regions are set of points. They are just set of points in subsets of R2. Okay, not any one. So plane so means they are described by inequalities and equations. Okay, combination of two. We will not be able to graph any plane regions, but simple ones that are delimited by lines or circles, we will be able to describe them using inequalities and equalities. Okay, so this is the purpose. So let's, for example, see the following. The following set, so it described the purpose of the exercise here is to describe the set of points, the shaded set of points. Describe the shaded region. Okay, so for example, suppose here um, that we have the unit -1 here, okay, -1, for example, or yes, -1. Then I can describe the shaded part here as the set of all points x, y. So let's write it here and start, yes, describing our set. So I see my set as the set of all points x, y, where in the plane are two, okay, such that what is what is how can I characterize the set of points? Their x first, their first coordinate, I see it that is less than -1, so I can write it x is less than -1. What about the second coordinates? The second coordinate, so here we are assuming the graph is continuing. There is no, so it's indefinitely, it goes up. It doesn't stop here. Okay. So there is no restriction in y's. So I can leave it. Either I stop here, I can stop or add y in R, but it's already, the information is already here. So if I don't write anything about y, I understand that y it can take any values. So here completely I'm describing my set. I didn't miss anything. Any point that has an first coordinate less than -1 is included here. Okay. Here we are assuming this limit line x equal a vertical line x equal -1 is included. That's why we put a less or equal. If the line wasn't included, we would put strictly less than -1. Okay. Similarly, how can we describe the set of points here? Here I can say that my set of points will be the set of points x, y, such that, so how can I describe a point in here? It has an x, so y, the y is above, for example, let's say 1 also here. Okay, this is y equal 1. So any points in this region has a second coordinate, because any point you can look at the projection, okay, on the y-axis to read the second component. So you will see it that remains greater than 1. Now, is there any restriction about x's? No, I can take any point. I see that I will be able to describe any values, negative values and positive values. Again, so here I will group all the points that have a y second coordinate greater or equal 1. Okay. Now, here we have two parts, okay, two parts in my shaded parts, okay. So this one, let's say, for example, I have here -2 or -3 and here 2. Okay, suppose that we have 2 units and here 3 units. Okay, -1, -2, -3. So I'm here at -3. So this first part, I can describe it, this first region, I can, or let's write it here. Okay, this part, I can, let's write it. E1 is the set of xy, like we follow the first example. So here, we can characterize this set by the points that have the first coordinates less than -3, while the second part here is E2. E2 is the set of points in the plane that have an x, okay, an x greater, so yes, greater or equal to. Yeah, no, here it is. Okay, okay. And now globally, how can I describe my set globally? I will say just my set E is the union of these two sets. Okay. Sometimes we can um, so depending on the quantities you are given here, you can maybe simplify your description, but here uh, we cannot simplify it. So I will just say x less than -3 and use or x greater 2 to say that either I have this situation or this. That means I'm regrouping both of them. Okay. Mm. Now, yes, another shape we know is the circle. With the circle, we can just form certain shapes and can describe our set. Okay. Otherwise, it's not easy, of course, to show. Okay. So, for example, this one is the unit circle, the shaded part. That means the limit of my the set um, is the unit circle. Inside the points that are included, that these are they are in the disk. Points inside the disk are we. So if you remember, the points on the circle, on this unit circle, let's write with the blue. So on the unit circle, we have x2 plus y2 equal 1 because the distance, okay, there's a distance, a point here, any point here to the origin, OP, we said it's square root of x2 plus y2 if you put your p with coordinates x and y. So we say it. I am on the circle, so my distance is 1. You take the square, the power to 2, the expression, and you get x2 plus y2. All points on the circle, unit circle, have the same distance, 1. Okay. Now, points are inside, so I can imagine my circle as a group, union of infinite circles inside. Okay. So finally, I will get circles, but with smaller radius. So my set, in fact, I can describe it. My set, I can describe it as xy in R2 in the plane, such that the distance to power 2 is less than or equal 1. Okay, that remains. So I'm looking all the points inside. So yes, I have square root less than or equal to 1 to be inside. I include all the points. So here is a description using unit circle, equation of circle, and then the concept of distance. So we are able to describe this set. Okay. Now, suppose that you have here, for example, 3 and 4. So you have a circle, the exterior circle has equation x2. They are centered at 0, so it's simpler. Y2 equal 4. Not 4. No, because we have the radius to the power 2. Power 2, that means either I decided 2. Yes. So I will decide it's 3 here, and this is 2. Okay. So let's erase. I will just change the value here and the value here. Yes, so that because yes, we need just, so let's say this one is 2 square, 2 units, 2 square, okay, which is 4. The radius is 2. Okay. But this is 1. Then here 1.5, 3/2. Okay, 3/2. Okay, so this circle is 3/2. So this circle, the second is x2 plus y2 equal 3/2 square. Okay, then the points that are between the two circles have distance. See, if you take a point here, a point P with coordinate x, y, its distance to the origin, if you look to estimate this distance, will be greater or equal 3/2 and less than or equal 2. Okay, so you can describe your set finally as the set of xy in R2 such that you have x2, so x2 plus y2, sorry. So either you say x2 plus y2. So if you want in terms of distance, you can say it's 3/2 less than 4, less than 2, sorry. Okay, but if you want to use more the expression of a circle referring to a circle, so then you have 3/2 square less than x2 plus y2 less than 4. Okay, so this is I added, so I use, we understand I need to have this inequality and this inequality. I need to be above this distance and less the other distance. Okay, many, yes, other sets, for example, we have also a situation like this one. Okay. Um, situation, yes. And a line, for example. Mm. Suppose that my equation is the following. This is y, and this is the line y equal x plus 1, for example. This is minus 1, x plus 1. So at minus 1, it's 0. At 0, it's 1. Okay, so this is my line. And suppose that I use, yes, the shaded part, this shaded part. Suppose I want the following part. So below my line. Okay, so this is what I want. All the region below the line. Okay, then here we can describe our set also. So A of xy will be, okay, the set here. Let's discuss, sorry. Okay, the set here will be A of xy. So AXY, okay, is equal to, sorry, without xy. Okay, so the set A is the set of points xy, so that the y, a point here, any point here, his x is here, his y is here, compared to the corresponding y for the other. This point y is less than the corresponding y for the same axis. Okay, for an A here, you have the image is here, the y corresponding, compare it to y that's of the point you are looking at. So all those points will satisfy less than the equation x plus 1. So this is, yes, how we do it.